Hello guys, welcome to my channel. And today I'm gonna talk about question 42 on LeetCode real quick. I'm gonna employ the two-pointer algorithm here. So one interesting observation on this question is the amount of water we can trap. For example, the zero here, which corresponding to this place in the graph. The amount of water we can trap here is dictated by the lowest number. So by the lowest number, the lower one, the lower of the highest number on either side. So towards its left, we know the biggest number is 2, and towards its right, the biggest number is 3. And the amount of water is dictated by the lower of the two. So which is, and the difference of them here in this case is 2 and 0. The difference is 2. And the difference is the amount of water that we can trap. And if we're using a two-pointer approach, and we also keep track of the biggest number that we have seen so far, and on each step, what we are doing is compare the number that is on each pointer, and if the pointer on the left is lower than the right, and then we know for sure that there might be some water that can be trapped on the lower side of the tube because if on the higher side, if there's no way that water can be trapped on top of it if it's the higher number. So and because we're also keeping track of the biggest number on either side that we have seen so far, we can just take the lower number of the two and compute the solution if there is any, and then we can move uh, the pointer on the side that we have just updated towards the middle by 1, and update any largest number that we have seen on that side if it's the case. So let me code this up. So we'll keep track of the maximum number we have seen so far on both left and right. So let's say left max 0 and right max is also 0. And also we want to also keep track of the use two pointers. So let's say I is equal to 0 and j is my right pointer that points to the rightmost element, which is I length minus 1. And as long as the two pointers doesn't meet, we'll continue the calculations. So we also need we need a counter to keep track of how many water we have found so far. And okay, so now first, like I said, we need to we need to check which side is lower by doing this comparison. And if the left side is lower, and then we know for sure that there's a chance that we might find some water trapped on top of the high I building, and the ice building. And so first, we can update the global max for left on the left side. So we can say left max equal to or it can be height I. And if the global max minus the current height is greater than 0, we know that this is a solution, so we can just add that. And otherwise, if the right side is lower, we know there's a chance that we might find some water trapped on top of this building. So we can update the right max global variable by doing a comparison of the right max and the current element that we're looking at. Oh, and here we also need to move the pointer by one. So move it right by one. If the right pointer is lower, we know we also try to attempt to find any water on top of this building. So the there's a height difference between the global maximum and the current building height. We know we have found some water, which is 1 max minus j. And then we want to decrement j by 1. And if they meet or cross each other, we'll exit the loop and the while loop, and we can just return some. Okay, so height. Right max. Right. I think this will do. All right. Thank you.